Hi there guys, I thought I'd make this quick video on quadratic modeling. I found this question. This is just from a standard Edexcel paper. You can find this pretty easily online if you want to get hold of it and try yourself. Or you can read it here, which is fine. So pause the video if you want to have a go at it, and then hit play when you're ready. Now there's lots of the hardest thing about this question is understanding what they really mean about horizontal distance. So we've got a graph. Oh, that's a bit dodgy, I apologize. Something like this. And there's an archer shooting an arrow. So this archer is not level with the ground. This archer he's actually standing on the ground. He's not in a tower, which they love towers in these questions. So he's 1.8, it's an average height, and he is shooting an arrow like so. I'm just going to extend that a bit. So D is the horizontal distance, there we go, and height, well, that's the height it goes up. Okay, so the flight path of the arrow can be modelled using a quadratic. And here we have this formula. Now in part A it says find the horizontal distance travelled. So it is this. Okay, so you've got to think, well, what happens here? How do we work this out? Well, this is a root, isn't it? This is a solution. So this is where h is equal to 0. So if we put when h is equal to 0, what we actually have is 0 equals 1.8 plus 0.4d minus 0.002d squared. Okay, so we just have to solve this quadratic. You can, if you've got the ClassWiz Casio or a slightly older model, you can just type this straight in and it would give you two answers. It's probably nice to show your working, use the quadratic formula, but you get D to be a negative. I don't actually know what that result is, but it's a negative result. And why that happens is it's given you this result here, which obviously is impossible in this real life context. And you also get 204 meters, and that's to 3 sig figs. Okay, so that's that. So this archer is firing an arrow 204 meters. Now part B, it asks for the significance of this constant 1.8, and you see this 1.8 here is when D is 0. If you pop a D to be 0 there, a D to be 0 there, this is the starting height of the arrow. It's 1.8. So that means this is the position of where the arrow is being fired from. I wouldn't go into too much detail saying the height of a person, because no one fires an arrow from the top of their head. It's actually from their eye line. So you could say eye height of the person. I would just simply say the height from which, the height above the ground from which the arrow is being released. I'm not going to write that down, but I've said it to you. So let's change that to a C. Okay. So when you look at this, as soon as you see this terminology, you've got to be saying, right, this is completing the square. So it's not the nicest one to complete the square on, but let's have a go. So I'm just going to write it out here and take you through step by step what I would do in my brain. So I've got a negative squared term, so I'm going to start this off by big square bracket and factorize for -1. So I get 0.002d squared minus 0.4d minus 1.8. Now there is a method, I've said this in my previous videos, you could take negative 0.002 out. I just don't. I just like it this way. So hopefully you're the same as me. If not, check someone else's video out on how to do it. Check with my answer. But this is a pretty common method. So I'm going to now, because there's not 1d squared, I'm going to factorize for this. What's that? That's going to be 200d, and that's minus 1.8. If you do factorize for all of this, you have a bracket and then a bracket, and that's why I don't like it. So now I'm ready to complete the square. So just a lot of rewriting. So complete the square, half this coefficient, and it's always, don't forget, always take away what that coefficient is squared, but we're not completing one square, we're completing this many. So don't forget, this is the only tricky bit, just remembering that bit. Just going to shift the paper over so it will fit on the screen. Minus 1.8. So let's tidy this up. So you can just type that into your friend. That's what I call a calculator, your friend. A bit weird, I know, but that's what I do. 21.8. And now all that's left to do is now multiply throughout by minus 1. So we get 21.8 minus 0.002 d minus 100 squared. So like I just said, if you've done it a slightly different method, just check your answer there. Okay, I'm just going to move it back this way so we can get the question, but we've got everything we need from it. Okay, so D, part 1. Now here you've got a different archer. So there's a new archer and the formula's been adapted. And looking at this, you'll notice that this is exactly the same, this is exactly the same, but that has changed. So what that tells me is, because it's a different archer, the fact that that's gone up, it means it's a taller person. That's all. Now if you think, because the curve itself is exactly the same, it's just got a different y-intercept. So what actually is going to happen, I'm trying to make it, as good as I can. It is going to go further, naturally, but it's meant to be like these heights here, they're meant to be equal. Okay, and like so, you can see it's gone a bit dodgy there. But it's going to go further. Okay, but this point here, its maximum point, happens at the same position. Okay, so we're going to talk about that later. So the maximum height of the arrow above the ground. So here's your maximum height there. And we can get that from our completing the square. So when d is 0 in here, that's going to equal 0. So all of this is going to equal 0. So this is the maximum height we're going to have from our first equation. Now we've got someone that is basically 0.3 meters taller. They're 0.3 meters taller. Yeah, it is meters. It's just going to go 0.3 meters higher at that top point. And the reason I know that is because these are the same. So therefore, I just have to add 0.3 on there. So I get 22.1 minus 0.0. No, I don't need to do any of that. So that's it, just 22.1 meters. But if I wanted to, that would be the formula for this new line. And in part 2, the horizontal distance from the archer when it's at its maximum height. So the maximum happens at the same horizontal distance, and you can use that by completing the square. So what value of d is going to give us our maximum? Well, when d is 100. So 100 meters. So that's a pretty tough question. 9 marks. It doesn't get much harder than that with quadratic modeling. So I hope that makes sense, and best of luck.